What if the James Webb Space Telescope has confirmed the one thing cosmologists hoped would never happen? For years, scientists believed the age of the universe was one of the most precisely measured quantities in modern science. Observations of the cosmic microwave background, distant supernovae, globular clusters, gravitational lenses, and numerous satellite missions helped construct a timeline stretching back nearly 13.8 billion years. Now, however, Webb has pushed farther into the cosmic dawn than any telescope before it. What it is finding appears, at first glance, to be too old, too massive, and too well developed to fit comfortably within that established timeline. A galaxy whose light has traveled for roughly 13.6 billion years should not already resemble a mature cosmic structure. It should not have had enough time to assemble, form stars, evolve, and become a recognizable galaxy. If Webb continues to discover galaxies this close to the beginning of cosmic history, the issue is no longer a single unusual observation. It becomes a much larger scientific challenge. The unsettling possibility is straightforward. Either galaxies formed far more rapidly than current theories predict, or some of our most trusted measurements and models of cosmic history are incomplete. Before Webb began challenging our understanding of the universe's timeline, it first demonstrated why it has become the most powerful astronomical observatory humanity has ever placed in space. One remarkable example is its observations of NGC 602, a young star cluster where Webb detected brown dwarfs beyond the Milky Way, providing astronomers with a rare opportunity to study substellar formation under conditions similar to those that existed in the early universe. Brown dwarfs occupy the fascinating boundary between stars and planets. They are too small to sustain hydrogen fusion like true stars, yet too massive to be considered planets. Thanks to Webb's powerful infrared instruments, scientists can now examine these elusive objects in ways that were impossible with ground-based telescopes. Webb also turned its attention toward the young stellar region in Taurus, where the system known as HV Tauri and its companion stars reveal the quiet processes involved in planetary formation. Around one of these young stars lies a disk of gas and dust that is still gathering material, flattening under gravity, and slowly preparing to form future planets. It provides astronomers with a glimpse of environments where entirely new worlds may eventually emerge. That is what makes Webb extraordinary. It does not simply observe objects that already exist. It watches stars being born, planetary systems taking shape, clouds of gas becoming organized structures, and dust gradually transforming into worlds. These breathtaking images are part of a much larger story. The same telescope that studies the birth of planets within our cosmic neighborhood is also looking back toward the birth of galaxies at the edge of observable time. And that is where scientific wonder begins to merge with profound questions. At the same time that Webb is challenging cosmology, it is also bringing humanity closer than ever to answering another historic question. Are we alone in the universe? One of Webb's most important targets is the exoplanet K2-18b, a distant world believed to possess a water-rich environment. Webb has detected atmospheric signatures of methane and carbon dioxide, along with tentative evidence for dimethyl sulfide. On Earth, dimethyl sulfide is strongly associated with marine microorganisms. That connection makes even a tentative detection scientifically exciting. It does not confirm the existence of extraterrestrial life, and scientists remain appropriately cautious. Extraordinary claims require extraordinary evidence. Nevertheless, the search has entered a new era. Instead of merely asking whether habitable planets exist, astronomers are now examining distant atmospheres molecule by molecule, searching for combinations of gases that may be difficult to explain without biological activity. Another fascinating target is the TRAPPIST-1 system, located about 40 light-years from Earth. This remarkable planetary system contains 7 Earth-sized worlds orbiting a small red dwarf star. Recent Webb observations have shifted attention away from some of the hotter inner planets and toward TRAPPIST-1e and TRAPPIST-1f, 2 worlds that may still retain substantial atmospheres and could provide some of the most promising opportunities to search for habitable conditions. If Webb eventually detects the right combination of atmospheric gases, suitable temperatures, cloud structures, and long-term stability, the first convincing evidence of life beyond Earth may not arrive as a mysterious radio transmission or the appearance of an unidentified spacecraft. Instead, it may arrive as a spectrum, a thin line of light from a distant planet, quietly revealing that Earth was never alone. Yet perhaps Webb's most uncomfortable discoveries are not found in nearby planetary systems. They are hidden within the oldest light in the universe. The telescope has confirmed extremely distant galaxies whose light has traveled for approximately 13.6 billion years, meaning these galaxies already existed astonishingly close to the beginning of cosmic history. That achievement alone is remarkable. The real challenge lies in what these observations imply about galaxy formation. If the universe is approximately 13.8 billion years old, then a galaxy observed only 13.6 billion years in the past had perhaps only 1 or 200 million years to form. While that may sound like an immense period from a human perspective, in terms of galaxy formation it is astonishingly brief. Gas must accumulate. Dark matter halos must collapse. Stars must ignite. Stellar populations must evolve. Large-scale structures must become sufficiently luminous for a telescope like Webb to detect them across billions of years of cosmic expansion. And yet, there they are. Galaxies appearing astonishingly close to the beginning of time itself. These discoveries are forcing astronomers to ask whether the earliest structures in the universe formed much more efficiently than current theories predict. Perhaps the first galaxies emerged within exceptionally dense regions of space. Or perhaps some aspect of the cosmic timeline itself remains incomplete.